prevention is heading and how we begin to take power back from a disease that has taken so much from so many. Welcome to the living room. Well, welcome. Thank you for coming. Let's start by talking a bit about how you got here, because you sit at this interesting intersection of, medicine, science, and a bit of philosophy. Why that path? And a secondary question, why did you end up then deciding on, dedicating your career to cancer prevention and treatment?
Great. So first of all, Chris, thank you for inviting me. It's really a pleasure to have this conversation with you and to be here. Um, this is an important question, right? We should always ask ourselves, why are we here, right? What are we doing? And for me, it really actually is something that started off quite personally. So to tell you my story, I'm a physician scientist and I do cancer research. Winding it back, it really started because I lost my father to cancer when I was 14 years old. He was 51. And it was terrible. It was just terrible. And I remember watching helplessly, basically, as he um, painfully died. And I wanted to do something about it. And in fact, I'd always loved science. My dad was a scholar, he was a philosophy professor.
I didn't know that.
Yeah, he was a philosophy professor, hence why philosophy.
Yeah.
Um, so, he was living the American dream. My dad was a Holocaust refugee from Vienna. He was actually one of the interpreters for the Dachau trials. He came to America, GI Bill, becomes a scholar, and he's living the American dream. And boom, age of 51, and he's gone. And it was devastating. I think it was especially devastating for him, but it was devastating for me too, as well as for my brother. And I wanted to do something. It's funny because my wife Deborah found my college essay, and in it I said I want to become a doctor and a cancer researcher to do something about it. And there were some wanders along the path, but that's been my North Star. And so my professional life has really been dedicated towards that. And my path was not a simple, straightforward one. First, I went to medical school. Literally met Deborah on the first day of it.
Is that right?
Yeah, literally.
So for context for the listeners, Deborah is also on our scientific council. Deborah is the co-director of the Stanford Longevity Center.
Yeah.
Interesting dinner conversations, no doubt.
Very much so.
Yeah. We'll get into that later.
Of course. And so I went to medical school, and then I trained as a pathologist, really because I wanted to look the enemy in the eyes. And I finished all of my training and realized I'd spend the rest of my life just looking at the enemy, and realized I needed to do something about it. So then I trained as a scientist. And then I came back, and this was early. So I started my first professional role as an independent assistant professor at UCLA in 1998. And just to give this context, this was just around the time of the sequencing of the human genome and the idea of precision medicine, that you could tailor a therapy for a person based upon their genetics. Now, I had gone to the lab of someone who was very extraordinary scientist who'd been the first person to climb both Everest and K2. It's really, his name is Louis Reichert, remarkable scientist, remarkable teacher. And I was doing basic science. And here I arrive at the university, and I am.
Don't risk losing the photos and videos from your phone. This innovative photo stick makes it easy to back up your smartphone and other devices. The best
Basic science. And here I arrive at the university, and I am putting RNA into frog eggs to study signaling pathways, and I can getting called to the OR to diagnose tumors. And I thought, what am I doing? Right? Shouldn't I be figuring out how to quantify and measure what's going on in these human cancers? So I started developing tools to do that. And that work took off. And my career grew, and I was moving up the food chain. And but there was a problem. People weren't getting better for the most part. And I kept thinking something was missing. And I hope I'm not telling you too meandering a story,
No,
but
you're not.
I want to tell you how it got
Yeah.
to the discovery that's really changed, I think, an understanding of cancer, or at least many cancers. And so the work was proceeding, but I kept feeling like I was missing something. And at the age of 50, right literally before the age that my father was when he passed away, I told Deborah and our daughters, Hannah and Sarah, let's go to Paris to do a mini sabbatical over the summer. In no small part because I wanted to spend time with my uncle Walter Michel, who was my father's brother. And Walter and I connected after my father died. And he became a father figure and a mentor and a friend. And I wanted to spend time with him. And we spent time in cafes in Paris just talking. And I vividly remember him talking with me about the importance of courage and about finding your own voice. And I kept thinking, we're missing something. And I made two decisions. I left the university where I was at, UCLA, and I went to a basic science institute. I was the only physician scientist in it because I wanted time. And I decided to look where the light wasn't shining. And that started a path that, with a move to Stanford 5 years ago and a sequence of events that's taken about 12 years, has, I think, changed our understanding of the fundamental mechanisms of some of the most aggressive forms of cancer. And I can tell you about it if you like.
Absolutely. Before we do that, actually, can you, given that this diagnosis, or we're all going to hear, or at least around 50% of us, perhaps, I don't know, correct me if I'm wrong, are going to either get that diagnosis at some point in our lives, but we're all going to hear about that. And we've all probably at some point either have been affected by that with our family or will be. Can you, at a very high level, explain what cancer even is?
Yes. And you're right. I think if you sit there and ask in a room of people, has your life been affected by cancer, either you're someone you love or yourself, every hand in the room is going to go up.
I agree.
Right? It matters a lot. And so then what is cancer? It used to be one thing when we didn't know much about it. But it turns out it's lots of things. And then the world has changed in terms of how we understand it. It used to be that the sort of way we would think about cancer was, where did it arise? Is it a breast cancer? Is it a colon cancer? Is it a brain cancer? And interestingly, that kind of morphologic, visual body part description remains the standard. When you ask people what kind of cancer is, that's usually the answer that they're going to give you. But the ability to interrogate the genes of human beings and their tumors has begun to change the game and provide a completely different level of insight into what cancer actually is. Because there are certain commonalities in how cancers come about that might make a cancer of one particular origin more like a cancer of a different type based upon its genes than those that actually look the same under the microscope and might need to be treated differently. So we're beginning to start seeing cancers in a different way, being driven by alterations in their genes. But then that's raised yet another complexity, which is it isn't just a deterministic sense of something going wrong with our genes. You can't disentangle our genes from our environments, and there's an interplay with the environment. So it's turning out that cancer is a very complex set of diseases that has at least one commonality. And that commonality is the fact that the cells in the body are supposed to listen to the central command. And in cancer, they have stopped listening to the central command and have gone rogue. That's the commonality. The reasons that they do it differ sometimes within an individual. So that creates a more complex landscape in terms of thinking about how do you diagnose this and how do you treat it. However, the amount of knowledge has moved so quickly, in no small part because of technological advances, that there's a much deeper understanding. And there are cancers that arise in certain ways and cancers that arise in others. Some of the simplest ones are, for example, and I don't mean to say that they're simple, but for example, virally developed cancers like human papillomavirus or cancers that arise from hepatitis. We understand those. Certain cancers we know come from germline, or meaning inherited defects like breast cancer and ovarian cancer that come from BRCA lesions, or Lynch syndrome,